Hello and welcome to another magnetic mailbox math movie where you get to play the part of the therapist and solve all maths problems. Today we're going to be in chapter 4, lesson 4, the last of this particular chapter. The title is Comparing Linear and Nonlinear Functions. Begins on page 170. I don't anticipate taking this section taking that long, so let's go ahead and get to work. We only have one term that we need to know, and that one term is a nonlinear function. Okay, non meaning not. And remember from the previous section, linear meaning line, so this is not a line. So when you graph this function, it doesn't have a constant rate of change, so it is not a line. Okay, go figure. Okay, it's not rocket surgery. Nonlinear is not going to be a line. Basically what this is saying is that from point to point, we may have different slopes. A line, or a linear function, will have constant slopes from point to point. Okay, here's example number 1. I just snapped a picture of it just because it's going to be quick and easy and we can talk about it and go on our way. The example number 1 is identifying functions from tables. It says, does the table represent a linear or a nonlinear function? And then we need to explain. Okay? So let's get this out of the way. If it is linear, it's going to be constant. Okay? And I'll show you what I mean by that. If it's nonlinear, it's not going to be constant. Let's look at table A first. All right? For x goes up 3, 6, 9, 12. So each jump it goes up by 3. That's constant, isn't it? Now let's check out the y. As x goes up 3, y does what? 40, 32, 24, 16. Okay, so the difference from 40 to 32 is negative 8. 32 to 24, they minus 8. 24 to 16, they minus 8. So everything is constant. When it's constant, we say that the rate of change is constant. The slope is the same, so the function is linear. You graph these points, 340, 640, 32, 924, 12, 16. Put them on a graph, you'll be able to draw a straight line through them. Now let's take a look at B. Okay, let's look at x. 1, 3, 5, 7. Okay, 1 to 3, you add 2. 3 to 5, add 2. 5 to 7, you add 2. Okay, so that's constant. We're good there, but let's check out the y. Right? 2 to 11, we add 9. 11 to 33, we add 9. Oh, no we don't. We add 22. Okay? So right here, we're not constant anymore. This is not a line. Just to make sure, 33 to 88, we're definitely not adding 9. We're adding 55. So although x is constant, y is not. Okay? It's going up by different amounts. So this is not linear. Okay? What this is going to be is if you were to graph this, and you don't have to right now, if you were to graph this, I'll just do it at the bottom, it would start to look like a line, but then it would start to curve. Okay? And as you know, a line is going to be constant. Okay? Straight. It doesn't change. Right? So A is linear, B is nonlinear. Here's example number 2, and I don't want you to overthink it because it is that easy. Okay? Does the graph represent a linear or nonlinear function? And then explain. Okay? Look at A. Is this a straight line? No. So it's nonlinear. Why? Because it's not a line. Simple as that, guys. Simple as that. Let's look at B. Here it is right here. Linear, nonlinear. Linear. Why? Because the graph is a line. Just like that. Okay, this is example number 1. This is in your book. I want you to see if you can figure this one out on your own. Unpause it and we'll work it through together when you're done. Alright, let's see what you got. Let's start with our x's first. From 0 to 7, we add 7. From 7 to 14, we add 7. From 14 to 21, we add 7. Okay, so the x's are constant. Now let's check our y's. From 25 to 20, we subtract 5. From 20 to 15, we subtract 5. From 15 to 10, we subtract 5. So as far as I can tell, we're constant on the x's and we're constant on the y's. So I would say that yes, this is linear. Alright, this is another on your own. I'm going to give you half a second to figure out whether this is linear or non-linear. Ready? Go. Right. This is non-linear, right? This is not a straight line. It's an upside down V, okay? So this one you can see right off the bat. Non-linear. Okay? That's the answer for that one. Okay, here's a few examples. You're going to tell whether or not these are linear or non-linear. In order to tell, you need, if they can be written in this form, slope-intercept form, y equals mx plus b, then they are linear. Okay? If they can't be written in that form, then they're not linear. So let's see what we have here. Pause the video and see what you can come up with for the first, second, and third one. All right, let's check the very first one up here. Okay, we have y. Remember, we want it to be y equals mx plus b. We have a y. The m is there. It's just not written. It's a 1. Okay, so we have an mx plus the b. This is in y equals mx plus b, so I can see without doing any kind of work that that's linear. All right. The second one is a little bit tricky. Okay? They have y equals 4x over 3. And you can actually rewrite that so it looks like this. Okay? When you rewrite it like that, the answer should be more clear to you. Y equals 4/3 would be your m, then your x. But what's your b? Well, your b is 0, right? If you wanted to put plus 0, you could, but it's not going to change your values any, okay? So this one can be written in y equals mx plus b. So this one too is linear. Right? Let's check out the last one. Y equals 1 minus x squared, and let's see if we can write that in slope-intercept form, okay? In slope-intercept form, the m and the x comes first, and then the b, so we would have to rearrange this, I guess. We could try. We could flip-flop it to where you go y equals a negative x plus 1. Don't forget the squared, because that's important, okay? Negative x squared plus 1. And an m would be the negative 1, but look, you have an x squared. In slope-intercept form, is the x squared? No, it's not. Okay? So this is not linear. Okay? This is not linear. This particular function is going to have two x's. It's going to be a parabola, which you'll get into in later math. But this, because of the squared, is non-linear. Okay? That's all we have for today. Short and sweet and to the point. Told you it would be fast. I will leave you with the joke of the day. And that joke goes like this. Why did the mushroom go to the party? Because he was a fun guy. Alright guys, hope you learned something. We'll catch you next time, and remember, you are loved.